Let's take a look at this expression. We have 1 in cell A0, B0, C0, D0. This is binary 0. I have 1 in cell 0. Now, this term is not completed. This term is missing B. In order to find in which cells I have to write ones, I have to expand this term. And let me show you how to do it. I have A0, C, D. I'm missing B. That's why I'm going to multiply this term by B or B0. And I'm going to have A0, B, C, D, or A0, B0, C, D. This is binary 7 and this is binary 3. 7, 3. This term is showing me that I have ones in cell 3 and 7. Let's go to the next one. I have another one, A0, B, C. This time I'm missing D. Again, I'm going to expand this term and I have A0, B, C. I'm going to multiply by D or D0 because this term is missing D. And I'm going to have A0, B, C, D, or A, B, C, D0. And I have also, of course, A0. And this is binary 7 and this is binary 6. 7 is already marked. So I finished with this one. This one is A, B0, C0, D. This is binary 9. Remember, the variable without the negation bar represents 1. The variable of negation bar represents 0. So I have 1, 0, 0, 1. This is binary 9. That's why I'm going to write 1 in cell number 9. This one, this term is missing D again. I have A, B, C0, and I have D or D0. I have A, B, C0, D, or A, B, C0, D0. This is binary 13, 1, 1, 0, 1, 1, 1, 0, 1, and I have 1, 1, 0, 0. This is binary 12. Okay, I finished with this term. This term has 4 variables, so this one is okay. So I have 1, 0, 1, 0. This is binary 10. Next one, I have A, B0, C0, A, B0, C0. This term is missing D again. That's why I'm going to multiply this term by D or D0. And I'm going to have A, B0, C0, D, or A, B0, C0, D0. This is binary 9. 9 is already marked. And this is binary 8. This is 1, 0, 0, 0. This is binary 8. I'm finished with this term. Let's go to the next one. I have A0, B0, C, A0, B0, C, and I'm missing D again, D or D0. I have A0, B0, C, D, and I have A0, B0, C, D0. A0, B0, C, D0. This is binary 3. It's already marked. and this is binary 2. Let's group these ones. I have one group of 4 ones. I have another group of 4 ones, and also I have another group of 4 ones. Let me remind you that Karnaugh map is like a piece of paper. If you are going to take 4 corners and put them next to each other, you are going to create the group of 4 cells. Let me start from this group. Let me start from a group which is placed in 4 corners. This group is placed in 2 columns and 2 rows. The common variable for this row and this one is B0. That's why I'm going to write over here B0. This group is placed in 2 columns, and the common variable for these 2 columns is D0. D0. Or, let's talk about this one. This group is placed in 2 rows. I have A. The common variable for these 2 rows is A. And the common variable for these 2 columns is C0. Or this group is placed in 2 rows and 2 columns. The common variable for these 2 rows is A0, and the common variable for these 2 columns is C. I'm finished with Karnaugh map. Let me check if we can do some modifications over here. I mean, if we can reduce the amount of gates in our circuit. We have exclusive OR, and if we are going to use the Morgan's theorem, we can convert this AND gate and 2 inverters to the NOR gate. So this is going to be B NOR D. This is this part of the expression, OR, and we have over here exclusive OR. So I have A, exclusive OR C. Let's take a look what we have gained so far. We have in the first expression 3 AND gates, 1 3-input OR gate, and 4 inverters. After the modification, we are going to have 1 NOR, 1 OR, and 1 exclusive. So we are going to have 3 gates over here. Now I'm going to implement this one because this one looks simpler. I have NOR gate with input B and D. I have exclusive OR gate with input A and C, and both of them are ORed together. These are the solutions to my problem.